Hello everyone, welcome to the 12.5 videos part 2, where we're going to go over numbers 5 to 8, which is all about going from a function, most of which we have to complete the square. I think all of them will have to at some point, and then we're trying to graph it. And so the first thing we need to do is identify what kind of conic it is based on what I see. For instance, if I look at number 5, and I rearrange things a little bit, usually the squareds are on the same side, so let me rearrange this one. If I have x squared, because I know I have to complete the square anyway, let's go ahead and put the 10x here. We add the y squared over, minus 6y. Let's move the 25 over also and get negative 25. If I take a look at the x squared and the y squared term, I notice both of them have a lead coefficient of 1, and they're both the same sign or both positive. So when that happens, even before completing the square, I know that this is a circle. So let me repeat that again. I know this is a circle because both of the squared terms have the same coefficient in front and they have the same sign, both positive. And so for this one, if I wanted to complete the square, I would, actually I already have it in the format to do so. So you know what? How about you pause the video and try to complete the square? Good news is you don't even have to take out a GCF because there's already a 1 in front. How exquisite indeed. So please pause now and complete that square. Alrighty, what I ended up doing was adding 25 to the first peat with a b over 2 squared, adding 9, doing the same on the other side, and I got this as my answer. X minus 5 quantity squared when I factor this, y minus 3 quantity squared when I factor that equals 9, because these 25s become 0. Because this is a circle, I do not need it equal to 1. That's only for an ellipse and a hyperbola, so this is my answer as a circle. And if I would like to graph that, what I need to know is what my center is and what my radius is. Well, my center would be at 5, 3, and my radius is the square root of 9, or 3. So if I went over to over 5 up 3, this would be my center, and then I would go 3 units in every direction. 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. So this would be a picture of my circle with radius 3. Example 6. Again, if I want to identify this, even before I start, I scan the whole problem and notice that there's only one squared term, which means this has to be a parabola, and I know that as a gut instinct before I start. If anybody else is really annoyed by this fraction, so am I. Let's get rid of it. Let's multiply the entire thing by 4 to get rid of the 1/4. And if I do so, the 4 would multiply the y, and I'd get a 4y. The good news is this 4 and this 1/4 cross out, so this remains untouched. So I'm left with x squared minus 2x plus 5 over here. If I want to rearrange the problem, I'm going to get the squared terms on this side and the non-squared terms on this side. So if I rearrange, I'm going to subtract the x squared over there, add the 2x equals, subtract the 4y, keep the 5 on the other side. Because this side does have a square, I'm going ahead and complete the square so I can get parentheses to know where the center is, or the vertex. I'm going to take out a -1, and I'm left with x squared minus 2x, because the sign changes, plus blank equals -4y plus 5 plus blank. 2 divided by 2 is 1 squared is 1. So I'd add 1 on this side also. Actually, no, I wouldn't. I would add -1 because we have -1 times +1. So we got a little -1 there. Good catch. So we have -1 times x minus 1 quantity squared, if I factor, equals -4y plus 4. So because I want parentheses on this side, I'm going to go ahead and factor out a greatest common factor of -4, and I will be left with y minus 1. Because I usually don't want a number in front of this x minus 1 squared, I'm going to divide both sides by -1. And remember, the numbers in front are only affected. So my equation is y minus 1 quantity squared equals +4 y minus 1. And again, remember, it is not the parentheses that change sign. So please, please don't make that mistake. Because this is a parabola and the x is squared, my parabola is either going to be facing upwards or facing down. Because I do not see a negative on this 4, my parabola is going to be facing upwards. And so the key things that I need to worry about is I need to figure out what my vertex is. I need to figure out what my p-value is. I need to figure out what my focus is. And I also need to figure out what my directrix is. Maybe the axis of symmetry also, if we would like to sketch this. So let's see. My vertex is going to be at 1, 1. So I'm going to go ahead and graph that already, 1, 1. My p-value is determined by this 4. And remember, this is really equal to 4p. So if I would like to find the p-value, I would set 4p equal to 4. So I'd get that p equals 1. And this distance p is the same distance from the vertex to the foci and from the vertex to the directrix. And because I know my parabola is going to be facing upwards, this would eventually be my focus point, and down here is going to be my directrix. And the directrix in this case is going to be a horizontal line through that point. And so I know that my parabola is going to be facing up. To figure out how wide the parabola is, the 4 represents the focal length. The focal length is 4, which means that from my focus, if my whole parabola is 4 units across, if I went 2 in each direction, my parabola would go through this point, through the vertex, through the other blue point, and would be facing up like this. And so if I wanted to find the other key information, my focus, I can see now is at 1, 2. My directrix is at y equals 0 because it's a horizontal line. And why not? My axis of symmetry is the line that cuts the parabola in half. So that would be x equals 1. All right, on to number 7. Let's identify this conic before we start. I look at both y squared terms, and I notice that the y squared terms, or the two squared terms, have different coefficients and different signs. So when that happens, before I start, I know it's a hyperbola. Different coefficients, opposite signs. And so what we're going to have to do is complete the square here, probably take out some lead coefficients. So my suggestion would be subtracting the 18, getting the x's together, getting the y's, and completing the square. So when you come back, I want you to pause, do this, and please check your answer with me. So please pause now. Okay, so here's my answer boxed in green. I got x minus 2 quantity squared minus y plus 3 squared over 9 equals 1. So please pause the video now if you need to stop and go through any of this information on your own. If we would like to graph this hyperbola, I'm going to go right into it. This is technically over 1. And because this term in a hyperbola is positive, I know that this is a horizontal hyperbola. So if I find my key information, I listed some when you were working on that. My center would be at 2, -3. So I'm going to graph that. My a value is not the largest value in this case. It is instead the number underneath the positive one. So the square root of 1 is 1. The b value is the square root of 9 or 3. The c value is found by c squared equals a squared plus b squared. So that would be c squared equals 1 plus 9. So c would be the square root of 10. To find my vertices, because this is a horizontally based hyperbola, I would start with my center, and then I would go 1 in each direction horizontally, because again, that's kind of the main axis here. And then vertically, I would go up 3, down 3, and I would make my little rectangle here, because hyperbola has asymptotes that we need to consider. So if I'm going to do a sketch so far, these two blue dots are the going to be where the graph actually is, because if my hyperbola is x-based, it has to be facing left and right. So this would be a picture so far. I also would need to find the equation of my asymptotes here. So I would go through the center, and I would go through the vertices of my diagonals of the rectangle here. And so before I get to the asymptotes, let me first list that my vertices would be at 3, -3, and 1, -3. My asymptotes would be, let's see, the center is at 2, -3. So it would be y plus 3 equals plus or minus. My slope is rise over run, up 1, 2, 3 over 1. So plus or minus 3 times x minus 2. My foci, because it is horizontally based here, we're looking left and right. And the coordinate, again, is 2, -3. So my x is changing. So it would be 2 plus the square root of 10, -3, and 2 minus the square root of 10, -3. So those values would really be at 5.16, -3, and -1.16, -3, which would be about here and about here. The next example 8, again, let's identify what this is before we start. I look at the two squared terms. I notice that the coefficients are different, but they are the same sign, which means that this must be an ellipse. Now again, what I'd like you to do is pause the video, and I would like you to complete the square on your own. There is something weird with a fraction that happens on this one, so I'll come back with you in a little bit, but please try what you can now. All right, guys, let's see how you did so far. My answer in red down here is how far I've gotten. If I completed the square, and again, please pause now if you need to check your work. If you got to this point, good for you. The one thing that's annoying is we still have a coefficient in front, which we can't have. So I do want to point out to you that the number 4/9 is the same as 1 over 9/4, if you think about it. Because if I take 1 divided by 9/4, if I multiply by the reciprocal, I would get 4/9. So what I need to do is rewrite this problem so the 4 is now in the denominator. So I'd have x minus 2 squared over 1 still, plus y plus 1 by its lonesome, but then on the bottom I would get 9/4 instead because of the reciprocal idea, equals 1. So this here, what I boxed as I paused the video, is going to be your answer. And what you need to recognize here is that the 9/4 in the denominator is larger than 1, so that means that 9/4 is a squared, 1 is b squared, so this ellipse has to be vertical. Sorry, I'm having a hard time writing with this today. All right, so we have a vertical ellipse, so let's find our center. The center has to be at 2, -1. So if I plot that point, it would be right here. My a value would have to be the square root of 9/4, or 3 over 2. My b value is the square root of 1, which is 1, and I will find my c in just a minute. But first, because this is a vertically based ellipse, my a value is going to go up and down. So 3/2 is really 1.5. So I would go up 1.5 this way, and go down 1.5 that way. My minor axis is the b value, and because it's left and right, I would go 1 this way and 1 that way. And so my ellipse is going to be very, very tiny and a little bit more vertically based. So it's going to be very small like this. So that means that my major vertices along this line would be at, so my major vertices would be here at 2, 1/2, and down here at 2, -2.5. My minor vertices would be at 1, -1, and would be at 3, -1. If I would like to find my c value, I have to use this Pythagorean relationship. C squared equals a squared minus b squared, because in the equation we have a plus here. So this is the point that I'd like you to pause and find the c on your own and try to find the foci. I'll be back with my answers in a bit. So when I did the Pythagorean theorem, I ended up having to do common denominators, got c to be the square root of 5 over 2. Because it's y-based, I added this and subtracted this value from the y value. So I got these answers exact and these answers as decimals.